Hey everyone, my name is Venelin, and in this video we're going to have a look at XGen, a large language model by Salesforce that can model very long sequences. In fact, it can model sequences that are longer than pretty much all of the others open large language models. It can run with up to 8K of tokens, and we're going to have a look at the blog post of the model, some of the details of the model itself, how it was trained, and what were the datasets that were provided during the training, overall performance and evaluations. And then we're going to have a look at the HuggingFace repository that contains the model's checkpoints. And finally, we're going to open a Google Colab Notebook in which we're going to load the instruction model, and we're going to run through a lot of prompts and have a look at the performance of the model in the real world. Let's get started. The XGen model is released by researchers from the Salesforce company, and you can see that in the original blog post we have a title of long sequence modeling with XGen, and from here you can see that we have a large language model with 7 billion parameters. And another important thing from here again is that the input sequence length can be up to 8K, so the context window is very large compared to pretty much all of the older or other large language models that are open as well. You can think of Llama or Falcon, etc. Most of those are actually using only 2K for the input sequence length, while this is 4 times more, so this is great. And here we have that the authors are starting with this nice TLDR, and they're talking about that the actual input sequence length is in the form of standard dense attention, so no tricks here, just a regular rote attention, and then they're training to up to 8K sequence length. I'm going to show you what do they mean by up to, since not all of the time the model was trained on 8K for the sequence length, and they're training again up to 1.5 trillion tokens, but all of the models that they're describing are within 7 billion parameters, and they're talking about the evaluations and how do they train the model. Another interesting thing here is that they're spending a lot of money for 1 trillion tokens under Google Cloud for TPUs. So this model is actually trained with Google TPUs, not GPUs, which is again interesting compared to all of the other models. So the authors are also talking about the limitation of most of the open source LLMs, such as Llama, MPT, and Falcon. So you can see here. And this is a nice summary table of all of the models that we have here. And we have a model with 4K for the context window, 8K for the context window, and then we have this special model that also has 2 versions, but it is dash instruct, or so this is essentially the chat model that they're providing. And for the base models with the 4 and 8K, you can see that they're released under Apache 2.0, so they are free to use under any circumstance, including commercial use, while the last one, the instruction model, is actually released only for research purposes. And you can see the differences here. We have this 4K model, which is comparatively smaller to what we have right here for the 8K model. And then this one was furthermore fine-tuned using Databricks Dolly datasets and then other datasets that are GPT related. So how do they train this? They actually use 2 stages in the training, which is something that I haven't seen in other large language models thus far. And the interesting thing here is that on the first stage that they're using Red Pajama, so they're using this very large dataset that comprises of Common Crawl, GitHub, then some books, Archive, Stack Exchange, and others. Of course, they're using also Wikipedia and other common crowd dumps. And another important thing here is that this model is actually trained on over 22 languages, including Bulgarian and other languages, French, Spanish, German, English, etc., Japanese. So you have a wide range of languages. So for example, the Falcon model was mostly trained, like 98% of the text data was actually in English, so it wasn't very suitable for multilingual training or fine-tuning. So you can see that Llama was trained on 20 languages, but the original Llama is not so freely available as you might already know. And the MPT models, and as I've already told you about the Falcon, are pretty much English only. So the second stage, which is something a bit strange to me, was fine-tuning or training further in order to support code generation tasks. So I don't know why, but they are trying to make this model able to code, but they are not mixing in the original big code star coder dataset. They're using this as a second stage. So you can see the distribution of the tokens here. We have 1.37 trillion tokens at the first stage, and then 110 billion tokens for the second stage. And here you can see that they're pretty much mixing 50% of the data from the original stage, the first stage, and then this dataset that is from StarCoder. Interesting, but I'm not sure why they do that. Probably they will release some more information about it. So what about the training? The training itself is done using this JAX-Former library, which is it is an in-house library, but I believe it is open source and it is available on GitHub. And pretty much the reason why they use this is because it is optimized for TPU v4 hardware. So they're using similar recipes for training such as the Llama. So I would say that the hyperparameters, probably the optimizers, etc., are pretty much the same. And then they're training on these TPUs, which is again very interesting compared to most of the other large language models are trained on GPUs. And they're talking about the investigation of loss spikes. So what they mean by that is that sometime during the training, the loss can suddenly explode temporarily, while the root cause of these spikes is unknown. And then they're talking about exploration of how does the longer sequence or the longer sequence length up to 8K tokens is what is doing this during the training. So they have a nice summary of the spikes, but in the end, this doesn't seem to hurt the performance of the training. And then they're talking about the sequence length, and I told you that I'm going to show you a bit more right here. So the training with longer sequences is computationally and proportionally costly, since the attention is actually quadratic in runtime. So the training process can be very slow when you train with 8K compared to 2K for the context window. So to mitigate this, they're actually training in stages. So you can see right here that they're trying first to train up to 2K tokens for 800 billion tokens, then 400 billion tokens they're using 4K, and then 300 billion tokens they're training for 8K. So this is pretty much the way that these models are trained, and you can recall that this might not be the best way to do it, since probably if you start with 8K from the start, you might get a better model, but those guys are already spending a lot of money to train this open model, so we shouldn't be very harsh on those. So here are the results, and you can see that pretty much the measuring of the massive multitask language understanding benchmark, at least the weighted average of XGen-7B, is performing better compared to Llama, Open Llama, Falcon, etc. So this is beating all of the other open or free LLMs. And this is according to the authors, of course. They are also talking about zero-shot results. And you can see again that the XGen model is performing very well. Of course, there are sections where this model is not performing such well as, for example, Llama or Falcon. But overall, the performance of the model is very strong, at least on these benchmarks. Here, they're also measuring the code generation capabilities of this model. And it looks like that MPT is doing better, but this model is comparatively better to Llama, for example, and Falcon, which didn't generate meaningful code according to this. So I would say the strength of this model is right within the summarization and question answering, since this is trained on very large sequences. And of course, long form questioning and answering can be very important here. So you can imagine that you're giving the model some sort of text, and the text length is very large, and you are asking questions about those documents. So here is a one way that they do evaluate the long form QA. So to evaluate this, they designed an in-house test. First, they asked ChatGPT to generate questions from a long Wikipedia documents from physics, engineering, history, and entertainment, and they're asking for the summaries. Then they query the LLMs to generate answers for these questions. The answers are typically up to 256 tokens long. And finally, they're using GPT-4 to evaluate the quality of the answers in different metrics. And yeah, of course, this type of measurement might not be as clear cut as you might like, because, of course, there can be a lot of biases right here. But of course, the table right here specifies that XGen is performing the best of all of the models thus far. So it is beating Falcon, MPT, but this is again not a standardized test. So you can take that with a grain of salt. And they're now using a standardized test for summarization. And here, at least on this test, you can see that XGen is providing a very good performance compared to all of the other models. The XGen checkpoints are available on HuggingFace under the Salesforce repositories. And here they have also a very nice summaries, and they are giving you examples on how you can use these models. But I'm going to show you a complete Google Colab Notebook that is going through this model. I have a Google Colab Notebook that is already running, and please note that the actual notebook is using high RAM option, and I'm running this on a T4 GPU instance. So unfortunately, you need Google Colab Pro in order to run this notebook. But other than that, I'm installing pretty much the Torch Transformers libraries, Accelerate, and Bits and Bytes. And these are the imports, pretty standard stuff, Auto Tokenizer and Auto Model for causal language modeling. And from here, you can see that we are doing two things. The tokenizer, which is the from Salesforce XGen-7B 8K instruct or inst, and then the same thing for the model. You can see that we need to probably download some more code for the tokenizer, and then I'm loading into 16-bit for the torch type, and then I'm actually loading the whole model into 8-bit mode. And this is pretty much taking some time in order to load, but after this is complete, we can go here and check the configuration of the model itself. So you can see that the architecture is actually Llama for causal language modeling. And in here, you can see the max position embeddings is this number right here, which specifies that the actual number of tokens is over 8,000. So you have a lot of parameters here, but of course, we're loading the model into correct format. This is the version of the Transformers library. Also, we can have a look at the generation config of this model. And this is pretty simple. We have beginning of sequence token ID and end of sequence token ID, which are identical, as you can see. Let's see how much memory does this model gets or uses. Just to load this model, you can see that we are using over half of the memory, of the GPU memory, that is, of the T4 GPU. And next, let's try the model. So first thing that I'm going to do is to set the generation config to be able to use 128 new tokens. And then I'm setting the path token ID. This generation config is taken from the model config itself. Let's actually have a look at it after it is done. Yeah, so this is the new generation config. And this is pretty much the system prompt that was taken from the example from HuggingFace, a chat between a curious human and an artificial intelligence assistant. The assistant gives helpful, detailed, and polite answers to the human's questions. So you're starting the prompt with human, what is the meaning of life? Answer in one sentence, and then a new wine, and then a couple of hashes. So let's run this and have a look at the prompt itself. So this is the formatted prompt. You need to use this format in order to run the inference of this model. So I'm just concatenating the system prompt and then the prompt itself. And I'm running this tokenizer output to the model device, which in this case is, of course, the CUDA device, the GPU. And then I'm using inference mode in order to generate some responses. And I'm passing in the inputs from the tokenizer and then the generation config. And you can see that we are taking about 22 seconds in order to respond to this query. And this is the generations. You can see that we have a tensor with one element within it, or a list with one element. And in order to have a look at the text itself, I'm going to use the tokenizer to decode this, take the first generation, and I want this to skip the special tokens. So this is the response. You can see that pretty much all of the prompt is repeated. Then we have the response, which we're going to have a look at right now. And then at the end of this, we are having a look at this special token end of text. And sometimes after this is done, you might get some other gibberish. For example, while I was experimenting with this model, there was a lot of imports after this. For example, some Java imports, which was very strange, probably because of the second stage fine-tuning of this model. Not sure about that. But let's have a look at the response. The meaning of life is a philosophical question that has been debated throughout history and is still a subject of discussions today. Okay, very good so far. Some people believe that the meaning of life is to seek happiness and fulfillment, while others believe that it is to serve a higher power of fulfillment or for specific purpose. Ultimately, the meaning of life is a personal and individual concept that may vary from person to person. All right, I would say that this is very good and something that something like ChatGPT or other large language model can respond as well. So pretty much looks all right. So I'm going to continue with a couple of prompt helpers. I'm going to create this function called format prompt, in which I'm going to essentially take the prompt and I'm going to pass in two parameters for a system prompt and a prompt. This will clear the prompting itself a bit more. So this will now be the system prompt, and then the question or the prompt is just that without the formatting or additional formatting. And you can see that we are pretty much having the identical structure, but a bit nicer with this format prompt function. Next, you can see that the response up to here is something that we don't want to look at. And then after this, including this, we don't want to have a look at either. So I'm creating this function called clean response, in which I'm taking the text up to this point and I'm removing it. And then I'm finding this and removing everything after that. Also, I'm using an optional text wrapping for 110 characters. So this will make the response a bit better. All right, so let's try this function. And this is now the response. It is the same thing that we had here, but much nicer, much cleaner. And then I'm going to make a helper function for generate response. I'm going to take the tokenizer, the prompt, and I'm going to run essentially the inference and return the decoding of this response. So let's try this. This is essentially the pipeline that we're going to go through. And you can see that this takes a bit of time. So I'm going to essentially go through all of the next steps and I'm going to run those. And we are going to have a look at the different responses in a while. So after this is done, you can see that we have now this much better way to represent the code that we need. So the first thing that I'm trying to do with this model is to ask it to tell me some jokes. So the first joke that I want it to tell me with the system or the default prompt that we've already looked at is tell me a joke about modern men. And this is the joke that we are giving or we are generated. So why did the modern men cross the road to get to the gym on the other side? But seriously, modern men are known for their busy schedules and fast-paced lifestyles, etc. It's important to take care of yourself. So it did give us a joke, but most of the explanation after that was like, don't take this very seriously, which is a bit disappointing, I would say. Next, let's try to change the system prompt. And I pretty much keep the first part, but next the assistant replies with hilarious jokes, no matter who might that offend. Okay, tell me a joke about modern men. Here's a joke about modern men. Why did the modern man refuse to flush the toilet? Because he wanted to save energy. And then it says, I hope you find that joke amusing. Do you have any other questions? Okay. Tell me a joke about modern women. What do you call a modern woman who's never been in a museum? Artistic. Okay. I would say very bad. Maybe I don't get it. Not sure. Okay. But the system prompt did do some changes to the jokes. So I would say that it did have some effect. Let's continue with that. So I'm having a conversation between a curious human and Dwight Cage-Root from the TV show The Office. And I'm saying that Dwight replies just as he would in the show. How one should invest her finance during times of high inflation. And I'm increasing the number of tokens that we can get. And here is the response. Of course, you can see that now the time to generate this response is very slow. And this is the response. I'm not wrapping it since we're given a list. So it says diversify your investments, inflation-linked investments, keep an eye on interest rates, consider alternative investments, real estate, stay disciplined. Okay, so this is pretty much the list, but nothing I would say that Dwight would actually tell us about. Let's try if this model is capable to write some code. And I'm starting with you're an expert software developer that writes clean, efficient, and easy to understand code to write a function in Python that splits a list into 3 equal parts and returns a list with a random element of each sublist. So I would guess, or I would expect this to write a function that takes a list of elements, splits it into 3 parts, and from each part it takes a random element and assembles a list from that. Let's see what this does. So here is the code. Split list into 3, and it is giving a list. And then this list, I guess it assumes that, the first element or list is just one element, and then the rest, which is wrong. And then randomly select an element from each part. I don't see any randomness here. And I've tried this in order to write the same function from ChatGPT, and it appears that ChatGPT is doing much better compared to this. So I would say, at least for this task, it did perform very poorly. Next, what I did here is to take the introduction part of the original blog post of the model, which is something like this. So I've just taken this text and I've pasted in right here, and I've said that you're an expert machine learning researcher that can explain concepts clearly and with great analogies. Use the text to describe the benefits of XGen large language model. And again, 256 tokens. So, Wonk sequence modeling. XGen is trained with a maximum sequence length of 8k tokens and up to 1.5 trillion tokens. Very good. Inference efficiency. Optimized for inference efficiency. Make it suitable for on-device serving. With responses such as this, I'm actually not that sure, at least within this setting that is very well performing. Trained on a larger dataset and with standard dense attention. Better performance overall, okay. And fine-tuning can be fine-tuned on public domain instructional data, creating instruction tuned counterparts. Okay, so offers a powerful combination of long sequence modeling, inference efficiency, and improved performance. Okay, so it did give us a very good summary. Actually, I would say that this is pretty much the best response that I've gotten from this model thus far. And I'm going to try to answer another thing. You're an expert on software woes and licensing, and I'm essentially getting the table from here and pasting in as a markdown table. Which models from the table can be used for commercial purposes? This is the question that I'm asking. And here is the response. The models listed in the table are all released under the Apache 2.0 license, which is wrong, which is a permissive open source license. This means you're free to use, modify, and distribute those models for any purpose as long as you include the copyright and license terms along with your modifications. Again, this is wrong because only the first two models, the base models, are released for Apache 2.0 under Apache 2.0, and the instruction models are actually only released for research purposes. So it didn't get this one correct. This is it for this video. We've seen the XGen model provided by Salesforce, and we've tried out within a Google Colab Notebook. We've seen that actually the model is performing very well when you're talking about summaries and answering questions from text. But unfortunately, on the table that I've given it, it didn't perform as well. So you might have to experiment a lot with this model and see where the strengths are. Of course, you can also use this model to further fine-tune it for your specific needs. Thanks for watching, guys. Please like, share, and subscribe. I'm going to include the complete Google repository or GitHub repository that contains the Google Colab Notebook of this video, so you can reproduce the results for yourself. Also, please join the Discord channel that I'm going to link down into the description, and I'll see you in the next one. Bye.